Hey guys, for Module 2 I went with a reverse mapping of a chromosome from a eukaryotic organism with 3 linked loci. The organism I chose was a hedgehog with a chromosome with 3 linked loci, which displayed the phenotypes of normal versus albino coloration, normal versus glaucoma eyes, and elongated versus pudgy body type. As you can see in the map on the bottom right, the loci for body color represented by A is 10 centimorgans from the loci of glaucoma represented by B, which is 13 centimorgan from the body type loci C. After crossing our pure breeding parents, we have many possibilities for what gamete our heterozygous individual will receive. The most likely scenario, with a probability of 71.31%, is there will be no crossover event, meaning that the heterozygous individual will receive one gamete from each parent perfectly matching that parent's gametes. Each of these gametes will also have a 35.66% chance of occurring. The next possibility is that we have a single crossover event in region 1. The probability of this event occurring is 8.869%. As you can see in the bottom right hand corner, you can calculate this probability by taking the percentage that a double crossover event will occur and subtracting it by the distance between each of those loci of 0.1 Morgan between the first two loci. This would be 0.1 minus by 0.01131, which equals 0.08869 or 8.869%. You will then divide that by 2 to get the probability of each loci of each gamete occurring, which is 4.435%. The next possibility is that we have a single crossover event in region 2. The possibility of this occurring is 18.69%, and as you can see in the bottom left-hand corner, this is pretty similar to the same calculations as if you have a crossover again in region 1. The possibility of each of these gametes occurring is 9.345%. Our final possibility, with a probability of 1.131%, is that we have a double crossover event occur. In order to calculate this double crossover event, you take the distance between each gamete, so 0.1 Morgan from A to B, and 0.13 Morgan from B to C, then multiply that by the coefficient of coincidence, which is 0.87 for this test. That will give you the answer of 0.0113. You will then divide that answer by 2 in order to get each gamete's probability, which is going to be 0.005655, which is going to be 0.5655% of each of them occurring. Thanks for watching, and go Pack!